The receptacles designed for computer control might not be suitable for high-power loads such as strip lights. Computer receptacles typically have a maximum wattage rating, and exceeding this rating could damage the receptacles or create a fire hazard. A solution is to use standard duplex receptacles rated for the appropriate amperage and wattage of the strip lights, for example, 20 amps, 120 volts. 16/2SJ with ground is an acceptable wire size for the strip lights, as it meets certain requirements. Firstly, ampacity. 16/2SJ with ground has an ampacity of 20 amps, which is sufficient for the 3 amp load of the strip lights. Secondly, voltage rating. SJ cable is rated for 300 volts, which exceeds the 120 volts used in the circuit. Thirdly, grounding. The wire includes a grounding conductor, which is essential for safety. Standard male plugs are suitable for use with 16/2SJ with ground wire. Ensure the plugs are of good quality and have a proper strain relief to prevent damage to the wire. During installation, keep the wire length to a minimum and avoid excessive bends or kinks. Tie-wrap the wire to the rod holding up the frame for support and prevent it from dangling. Install the lights and plugs according to the manufacturer's instructions. The 20 amp branch circuit should be protected by an appropriately sized circuit breaker or fuse. Recommended implementation. 1. Replace the computer-controlled receptacles with standard duplex receptacles rated for 20 amps and 120 volts. 2. Use 16/2SJ with ground wire with standard male plugs to connect the strip lights to the receptacles. 3. Tie-wrap the wire to the rod holding up the frame for support. 4. Ensure the circuit is protected by an appropriate circuit breaker or fuse. When selecting and installing electrical components and wiring, it's crucial to adhere to the National Electrical Code, or NEC, and any relevant local codes. The NEC provides comprehensive guidelines for safe electrical practices covering wire sizing, overcurrent protection, grounding, and installation methods. Always consult the latest edition of the NEC and local amendments to ensure compliance. Proper wire sizing is essential to prevent overheating and potential fire hazards. The ampacity of the wire must be sufficient to carry the intended load. Refer to NEC Table 310.15b16 for allowable ampacities of insulated conductors rated up to and including 2000 volts. Consider the ambient temperature and apply correction factors as necessary. Overcurrent protection devices, such as circuit breakers or fuses, protect the wiring and equipment from overloads and short circuits. The rating of the overcurrent protection device should not exceed the ampacity of the wire it protects. Grounding provides a low impedance path for fault current to return to the source, minimizing the risk of electric shock. All electrical equipment and enclosures must be properly grounded. Use approved wiring methods and materials suitable for the environment. Securely support and protect wiring to prevent damage. Follow manufacturer's instructions for installation and maintenance of electrical equipment. If you are not qualified to perform electrical work, hire a licensed electrician. Working with electricity can be dangerous, and improper installation can lead to serious injury or property damage. Electrical safety is paramount. Always to energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Test circuits to ensure they are de-energized before handling wires or equipment. Be aware of potential hazards such as exposed wires or damaged insulation. If you are unsure about any aspect of electrical work, consult a qualified electrician. Electrical systems operate on various voltage levels. Understanding these voltage levels is crucial for safe and efficient operation. Common voltage levels in residential and commercial buildings include 120 volts, 208 volts, 240 volts, 277 volts, and 480 volts. 120 volts is typically used for lighting and small appliances. 208 volts is commonly found in three-phase systems and is used for powering larger equipment. 240 volts is often used for electric ranges, water heaters, and air conditioners. 277 volts is used for lighting in commercial buildings. 480 volts is used for large motors and industrial equipment. When working with different voltage levels, it's essential to use appropriate equipment and wiring. Ensure that all electrical components are rated for the voltage they will be subjected to. Use caution when working with high voltage systems, as they can be lethal. Always follow safety procedures and consult a qualified electrician if you are unsure about anything. Electrical circuits can be wired in different configurations, such as series, parallel, and series parallel. In a series circuit, components are connected end to end, so the current flows through each component in turn. The total resistance of a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected side by side, so the current has multiple paths to flow through. The total resistance of a parallel circuit is less than the resistance of the smallest individual resistor. Series parallel circuits combine elements of both series and parallel circuits. Understanding circuit configurations is essential for troubleshooting and designing electrical systems. Use appropriate wiring methods for each type of circuit. Follow the NEC guidelines for wiring and protection. When working with electrical circuits, it's important to understand the relationship between voltage, current, and resistance. Ohm's law states that voltage equals current times resistance, or voltage equals current times resistance. This relationship can be used to calculate the current flowing through a circuit, the voltage drop across a component, or the resistance of a component. Understanding Ohm's law is essential for troubleshooting and designing electrical circuits. Use a multimeter to measure voltage, current, and resistance in a circuit. Be careful when working with live circuits, as they can be dangerous. Always de-energize circuits before working on them. Electrical wiring comes in various types and sizes, each with its own specific applications. Common types of wiring include non-metallic sheath cable or NM cable, also known as Romex, which is used for residential wiring. Armored cable or AC cable, also known as BX cable, which is used for wiring in metal studs and other applications where physical protection is required. Metallic conduit, which is used for wiring in commercial and industrial buildings. Underground feeder, or UF cable, which is used for underground wiring. The size of the wire is determined by its ampacity, which is the amount of current it can safely carry. Refer to the NEC tables for wire ampacities. When selecting wiring, consider the voltage, current, and environment. Use appropriate wiring methods for each type of wiring. Follow the NEC guidelines for wiring and protection. Electrical panels are the central distribution points for electrical power in buildings. They contain circuit breakers or fuses that protect the individual circuits. Electrical panels must be properly sized to handle the expected load. They must also be properly grounded to provide a safe path for fault current. Inspect electrical panels regularly for signs of damage or overheating. Replace any damaged or worn components. Keep electrical panels clean and free of obstructions. Follow the NEC guidelines for installation and maintenance of electrical panels. Electrical grounding is an essential safety measure that provides a low impedance path for fault current to return to the source. This minimizes the risk of electric shock. All electrical equipment and enclosures must be properly grounded. Grounding electrodes, such as ground rods or ground plates, are used to connect the electrical system to the earth. Grounding conductors, such as green wires or bare copper wires, are used to connect equipment and enclosures to the grounding electrode. Inspect grounding systems regularly for signs of damage or corrosion. Replace any damaged or worn components. Follow the NEC guidelines for grounding electrical systems. Electrical bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. This helps to equalize the voltage potential between different parts of the system, which reduces the risk of electric shock. Bonding conductors, such as bonding jumpers, are used to connect metal parts together. Inspect bonding systems regularly for signs of damage or corrosion. Replace any damaged or worn components. Follow the NEC guidelines for bonding electrical systems. Electrical surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning, power outages, or other events. SPD diverts surge current away from sensitive equipment, preventing damage. SPD are typically installed at the service entrance or at individual equipment locations. Inspect SPD regularly for signs of damage or failure. Replace any damaged or failed SPD. Follow the manufacturer's instructions for installation and maintenance of SPD. Electrical safety audits are comprehensive assessments of electrical systems to identify potential hazards and ensure compliance with safety standards. Electrical safety audits are typically conducted by qualified electricians or electrical safety professionals. The audit includes a visual inspection of electrical equipment, wiring, and grounding systems. It also includes testing of electrical circuits and equipment. The audit report identifies any hazards or deficiencies and recommends corrective actions. Implement the recommendations of the audit report to improve electrical safety. Schedule regular electrical safety audits to ensure ongoing compliance. Electrical maintenance is essential for ensuring the safe and reliable operation of electrical systems. Electrical maintenance includes tasks such as inspecting equipment, cleaning components, tightening connections, and testing circuits. Regular electrical maintenance can prevent equipment failures, reduce downtime, and improve safety. Develop a comprehensive electrical maintenance plan. Train personnel to perform electrical maintenance tasks. Keep records of electrical maintenance activities. Follow the manufacturer's instructions for maintaining electrical equipment. Electrical troubleshooting is the process of identifying and resolving problems with electrical systems. Electrical troubleshooting requires a systematic approach and a thorough understanding of electrical principles. Use appropriate tools and equipment for electrical troubleshooting. Follow safety procedures when working with live circuits. If you are not qualified to perform electrical troubleshooting, hire a licensed electrician. Electrical fires can be caused by a variety of factors such as faulty wiring, overloaded circuits, or damaged equipment. Electrical fires can be extremely dangerous and can cause significant property damage. Prevent electrical fires by following electrical safety guidelines. Install smoke detectors and fire extinguishers. Have electrical systems inspected regularly by a qualified electrician. If an electrical fire occurs, evacuate the building immediately and call the fire department. Electrical shock occurs when a person comes into contact with a live electrical circuit. Electrical shock can cause serious injury or death. Prevent electrical shock by following electrical safety guidelines. Use appropriate personal protective equipment, such as gloves and safety glasses. Never work on live electrical circuits. If someone is experiencing electrical shock, do not touch them. Call emergency services immediately. In summary, when dealing with electrical work, safety and compliance with the National Electrical Code, or NEC, are paramount. From selecting the right wire size and understanding voltage levels to implementing proper grounding and surge protection, every step must be taken with caution and precision. Regular maintenance, audits, and troubleshooting are essential for ensuring the ongoing safety and reliability of electrical systems. Always prioritize safety and consult with qualified professionals when in doubt.